In this video, I want to go over some miscellaneous settings within the principled shader and also go over how this all relates to the theory that we just learned, because right now that seems a little bit detached in what's happening. So, start off with the coat though. I want to show you guys how to plug in texture maps here. So, we're not going to use the color picker. Instead, if we go to the Textures tab, check on this base color, and I'm going to browse for a texture that I made ahead of time. So the smooth leather number 4, right there. And as you can see, it applies it to ShaderBot. Now, what's happening here, and the important thing that you should know, is that whatever this texture map comes up with, that's going to get multiplied against whatever settings you have here in this tab. And that's true for the base color, it's true for specular parameters in here. Any textures you have in here, it's just multiplying against these values. So that means if you have a base color and it's, something like this, it's going to take this color and multiply it against the texture map, and that's obviously not what you want. So, long story short, just set that to 1 and you're good. Okay, so besides that, also feel free to take this albedo multiplier and bring that to 1 if you need to. I'm going to do that for this particular texture. And then under the settings tab, because this is a repeatable texture, meaning that you're not going to see the map repeat itself, if you want to repeat it many times, go ahead and turn down the scale, and that should repeat the texture map multiple times across the surface. So that means 0.25, it's repeating 4 times. If I brought this to a scale of 1, you'll notice that I've basically just scaled up this texture map. So anyway, I like 0.25. I think that works pretty nicely in this situation. And there we go. I'd also like to add a bump map. And so just in case you're not familiar with what a bump map is or how it works in general, let's go over that real quick. Here's a map. This is what a bump map might look like. It's a black and white image. And those pixels will basically cause a bunch of bumps to happen on the surface. Any areas that go towards white will cause these bumps to go away from where the surface was before. And as we go towards black, it goes inside the surface. If the value is 50% gray, then nothing changes. Bump maps get used to break up highlights and add very fine detail to your materials. Now, don't get this confused with roughness because it's not the same thing. Whenever we describe roughness, we're talking about a scale that's even smaller than this. We're talking about maybe a scale that's like this. I mean, you can see how pixelated this is on my screen, but roughness is not at the same scale as what a bump map does. It's a different thing, but a bump map is like one scale above what roughness is trying to do. Anyway, I have a few tips on this. One tip here is to judge your bump map by looking at the highlights. The main purpose for bump maps is to break up your highlights and to add very small detail. That's bigger than roughness, but still very small in general. Also, don't try using a bump map to capture medium to large size details. It just doesn't work very well. And it's also better to use a normal map for medium sized detail and a displacement map if you're trying to do larger size details. There's really not much to it. You just need to go to Bump and Normals, say Enable, and then find the bump map. So again, I have this texture made ahead of time, so I'm going to just use that leather bump. And right away, it's going to be way too much. One thing to also know about bump maps is that it's not ever going to actually change where your geometry is. What you want to do is say the effect scale is something really small, 0.001 to start. Let's zoom in to an area that has a highlights, like right around here. For bump maps, I like zooming in a lot. And then again, we're just trying to get a little bit of this effect. So 0.001 might honestly be perfect. If we go less than that, see what that looks like. And I think even right there, that might be it. Let's go in between, split the difference, 0.00075. Again, it's a very subtle effect. And I think that'll be what we're after. Okay, so there we go. I'm going to send off a render for this leather. We'll see what it looks like, and we'll move on. All right, and there we go. Now we have a basic leather shader. So now that we've been through those exercises, let's talk about the principled shader for a minute, because what's interesting is that we don't have diffuse weight. We don't have specular weight. Instead, all the parameters that I changed just involve the base color, which is the absorption component, IOR, roughness, and metallic. And the idea with the principled shader is that all the details we just talked about in the theory section, a lot of that's getting handled under the hood. In other words, if you set your base color, your IOR, your metallic, your roughness to the values that they need to be, all of the correct weights will get generated automatically by the principled shader to give you a realistic result. The principled shader was designed so that if you wanted to have artistic control or just a artistic opinion to do something, you can just do it and then things will magically find themselves in a physically plausible scenario. That's the idea with the principled shader. However, it's still good to know how diffuse reflection, specular reflection, metallic, all that stuff works in general, because it's going to help you analyze things in the real world and understand how that can translate. For the remainder of this lesson, let's cover some miscellaneous topics, and then we'll move on to transparency and subsurface scattering to finish things off. Starting with anisotropy. Anisotropy is a way of describing the way in which the roughness is shaped on the surface. So we mentioned that roughness describes all these different micro variations on a very, very small scale. Well, if something is anisotropic, what that basically means, and I'll just draw over this real quick. What that basically means is that we still have roughness going on, but instead of roughness just being, something random like that, it actually has a pattern to it. And so we end up with something maybe like this in the roughness. It's kind of this sawtooth pattern. And what happens is that, well, we mentioned that the roughness has a very big impact on specular highlights, right? So if the roughness begins looking like this and it's not all random, then we start getting these interesting lines that occur with the specular highlights. And it also changes the direction in which the highlights can originate from on the object. So in practice, I have this shader ball here. The anisotropies turn up to 1, and we have this anisotropy direction. This direction is basically telling those sawtooth grooves which way they need to go. So if I go like this, as you can see, this highlight changes its direction. Now, where might you need to use this with? Well, if you have brushed metal, you want to use anisotropy. It's really important because brushed metal typically has these grooves just due to the way that it was manufactured. And, actually, you can just Google anisotropic highlights and you'll find all kinds of interesting things. Here we have a great example right here of these swirls that occur on metal. Right at the bottom of this pan, that's another example of an anisotropic highlight. And so, again, it's a very specific situation, but if you're ever looking at reference and you notice that the highlights kind of have a particular direction to them, then you might want to consider using that particular setting. We also have another miscellaneous setting with Sheen. Sheen is there to basically account for a very, very subtle diffuse roughness. You know how I said roughness doesn't really impact diffuse reflections? Well, that still remains true. However, there is a very slight effect when, let's say, you have fabric, and fabric has all these very, very tiny little hairs that pop out at the very end, and it causes this glowing effect as you reach a glancing angle. And so it's not really Fresnel because it's not a specular reflection, but it is a noticeable effect. So that's why we have Sheen. And basically, it just adds a little bit of intensity to your Fresnel. And it doesn't really do a glossy Fresnel on that. In practice, it's very, very subtle. Look at the top of this, and then look at the top of that. This is with Sheen. It's a little bit brighter than that, but it's very, very subtle. So, for the most part, you really don't need to use it. But I would say that if you have, let's say, felt or some sort of cloth, and you notice a bit of a glowing, effect towards that Fresnel angle, then go ahead and add a bit of Sheen, and you're good to go. The only time I ever use emission right here is when I have particles flying around and I have, let's say, an ember that blurs out and dies really quickly. Emission is meant to replicate the behavior that, that materials that emit light might have. So the classic example would be a light bulb. The reason why I say I don't recommend this is because unless you're working in video games and you want to save on rendered computations, it's better to just use a light whenever you're trying to light something up, because at least with the light, you have control over the exposure with everything else around the object. But just so you know, that's what emission is there for. Again, in practice, I only use it on particles. And then the last, I'd say, fairly miscellaneous parameter here is the coat parameter. The coat parameter, though, can be pretty awesome depending on the situation. So let's say that I want to shade some sort of plastic, and I've noticed that there's a couple of highlights going on. We have a broad highlight, and then we have another highlight that's more focused. So just to give an example here, I'm going to take this coat value to 0, and then the roughness here, let's leave that at 0.4. So we have these broad highlights around here, and now I want to layer on a coat. So that's exactly what happens. We have sharp highlights combined with broad highlights. And so, anyway, the coat does that. It's just another way of adding a layer of specular reflection, direct specular reflection, that is. And this is very useful for anything that has a lacquer on it. It's very nice for plastics. It's very good for car shaders and things like that. Like I said, anything that has a coat or a layer of finish on it usually can benefit somehow from this coat setting. You also have different roughnesses that you can assign, so it doesn't have to be a roughness of 0. I've used the coat before to give really more complicated specular highlights to things. So if you want to combine, let's say, a roughness of 0.2 with 0.4, that can give you some interesting looking results. And just depending on the material and whatever it is you're doing, if you ever want 2 highlights to play with, that's what you would use. In the next video, let's talk about transparency. I'm going to get back into IOR a little bit more, and then from there, we'll do a quick exercise. We'll do the same thing with subsurface scattering, and then I have a challenge for you at the very end.